In this section, we are going to be looking at lines of best fit, or what's sometimes called a linear regression. So you'll need your calculator for this, so make sure you have your calculator there with you. There is doing for us here. So this graph right here has a graph where our base height here says flag height, or our base, our x-axis here says flag height, and our y-axis is our shadow location. So if you think of a flag pole that you have here, the flag is a certain height as it's being moved up the flagpole. So you're moving the flag up the pole. So the flag is getting higher and higher as your little cadets are here adjusting the flagpole. So the flag is moving up. Well, as the flag moves up, then the shadow should get longer and longer and longer that we see here, or that shadow here that we see of the flag, it should be moving in this direction. So we see several different data points that were taken. So this particular problem we're going to do just by looking at the situation. So if we took a line, we could try to fit it as best we can. We could just draw it in. That looks pretty good. You can move it up, down. I could pick a couple points that kind of fall on that line. So if I look at those points, the coordinates of this point is 6, 2. And the coordinates of this point is 27. Now be really careful with this, because notice here between 4 and 8, halfway between that is 6. So each unit on our x-axis is worth 2. So we need to be really careful. If we try to count our slope, we have to keep that in mind. I think I'll just use slope formula. So 7 minus 2 over 20 minus 6. That is going to give me 5 over 14. So the slope of this line is probably about 5 over 14. And then if I look at my graph, it looks like the y-intercept is down here a little below 0, so maybe negative 1/2 if I'm estimating. So that would mean the equation of this line is y equals 5 over 14x minus 1/2. So in this case, I could use this line to figure out, maybe let's say that we were at 12 feet. I would hope that I could figure out the height. That looks like from the graph here that should be about 4. If I plug in to the equation 5 over 14 times 12 minus 1/2, if I plug in 12, let's type that into our calculator. 5 over 14 times 12 minus 1/2. Whenever I do that, I get 3.7857, which 3.7857 would be really close to 4, so that looks pretty close to what I've got here, and it gives us a decent prediction. That line can be used to predict. However, I have just sort of eyeballed this. It's not the greatest estimation that I've ever done. So the calculator's line is much better than the line that we're going to use here. So what we're going to do is use the calculator's line instead. Now, I don't have the data points for this exactly, so we're going to use a different situation so that you can follow along with what we're doing here. Before we can actually do what we want to do here, we need to turn our diagnostics on the calculator so that it will give us what we call a correlation coefficient. The correlation coefficient is also sometimes called the R value. So that correlation coefficient tells us how closely the data fits the line that we're creating. So we'll look at it a little more in a moment. So pause the video here real quick and copy down these instructions so that you can refer back to them. And then once you have those copied, rejoin me, and whenever you do that, we are going to, on our calculators, we are going to press second and 0, and it takes us to the catalog. The catalog here has a list of everything that your calculator can do. And we want to turn our diagnostics on. So we're going to go down to the D's. You can just scroll down, or if you just hit the X to the -1 button, see that little green D over there in the corner, it'll take you down to the D section, and you can scroll down here till you see diagnostic on. So we're going to click enter for diagnostic on, and then you have to hit enter one more time. You have to make sure that you see done right here. And so now our diagnostics are turned on for this calculator. You do not have to do this before every problem. You only have to do this one time, and they will stay on until you either turn the diagnostics off, or if you reset your calculator, second plus sign 712, if you reset your calculator, then it will turn the diagnostics back off, and you'll have to repeat this step. But right now we should be good for our diagnostics being on, so we'll continue on to our next step. So if you will again, pause the video here and copy down these steps because you will need to refer back to them. So copy these down, and then once you have finished copying them, you can rejoin me on the video. You'll see over here that we have a table here that we are going to be using, and I've just sort of created a table, a short table here for an example, and this table gives us the age of a student and the grade that they are in. So we are going to follow these steps here to find a line of best fit. So what we're going to do first is we are going to press Stat, and we're going to choose number 1, Edit. You'll notice that I already have stuff here in my L1 and L2. Your calculator may have that as well. If that is the case, then if you hit the up arrow until you get to your L2 and you hit clear and enter, then it will clear out that list for you. Or another option is that you can just hit delete, and it will take those entries in take those entries away one at a time. It takes a little longer to do that. I do want to warn you of something here. If you go up here and select L1, but instead of hitting clear, you hit delete, then if you look, L1 is gone, and even when I scroll over, I don't have an L1 at all. If this happens to you, if you'll press Stat and number 5, which is Set Up Editor, and enter, then it will fix the problem. So if you go, now if we go back, Stat, Edit, then I can see the L1 has returned. So I'm going to clear out my L1 here, and L1 and L2 are both clear. Now if your L1 and L2 were clear, you were good to go. So now we need to enter our data into L1 and L2. We're going to enter our independent variable, or our X, in our L1. So that's age here. So 7, 10, 13, 14, and 18. So we enter those values into our X. We're going to go over here to L2, and we're going to enter our Y values. So 2, 4, 7, 9, and 12. So follow along and type those in your calculator. Also, now that we have our data entered in, our lists are the same length, everything looks correct, we are going to hit Stat, and we're going to go over to the Calc menu. This is where you perform any calculations with the statistics that you just put in. So we can see that we're supposed to choose number 4, LNREG AX plus B. I don't know why they didn't just call it MX plus B like we are used to seeing, but this is going to give us the equation of a line here. So we are going to choose this one. We'll hit enter to choose that one. And before we hit enter again, we are going to do these steps here. These steps that we see right here, they store our value in Y1. So what that will do is that will allow us to see that line whenever we graph it. it's going to look like it doesn't really do anything, but it stores it in Y1 for us. So before we hit enter, we're going to hit bars. We're going to go over to Y bars. We are going to choose number 1, which is function, and then choose number 1, which is Y1. Okay, now we can hit enter. And when we do that, we get all of this stuff right here. But what this is giving us is the equation of a line. So notice it says up here at the top, y equals ax plus b, but then it tells us that a is 0.945086705.2, and b is negative 4.919, and so on. So those are our values for our equation. So we are going to have y equals I'm going to put a 0 here, 0.945. Let's keep 3 decimal places. If you keep more, that's okay. X plus the b, or the y-intercept. Actually, I should probably not use a plus there, because my y-intercept that we see here is negative 4.919. So let's put minus 4.919. So this is the equation of the line that I'm given. These values that we see down here, if you do not have these, then you did something wrong when you cut your diagnostics on at the beginning of the video. Here, these should show up, and these are our correlation coefficients. So this R here, that is our correlation coefficient. If it is close to 1, which this one is, that tells us we have a pretty good fit here. If it is exactly 1, it tells us we have a perfect fit. If we were to have a smaller number here, like 0.7, then our fit would not be so great. If we had a really low number like 0.3, then we would have a terrible fit. It wouldn't really fit at all. If you get really low numbers, that should sort of indicate to you that you probably messed up somewhere, because most everything I'm going to give you is going to have some correlation. Now, of course, if you're doing research in the real world, it's very possible that you might get a low coefficient here telling you that your data is not really related. But for the problems I'm going to give you in class, you should not get really, really low numbers for that R. The R squared is just this value squared. And we'll learn more about the R squared whenever we get close, whenever we start doing quadratics. We're going to have that R squared value to compare our fit to a quadratic fit. But right now we really just care about this R value here. We also want to know what this looks like for our data. So if we go over to this next slide, it has the directions for us to graph a scatter plot. Our calculator will graph this information for us, so we want to do that. So pause for a second here, pause the video, and copy these instructions down. And once you have those copied, then you can rejoin me on the video. So to graph a scatter plot, the first thing we're going to do is enter our data in L1 and L2. We have already done that to get our line of best fit. Then we will press second and the stat plot second and y equals to get to the stat plot menu. So we press the second button and the y equals button. You'll notice the blue letters across the top that say stat plot, and that is where we want to go first. We must turn the stat plot on before we can graph these. If we don't have the stat plot on, it will not graph our points. So we're going to press enter to choose number 1. We'll press enter again to turn this on. Notice now how on is highlighted and off is cleared out. And then we will press window. So this turns our stat plot on. Then we want to go to our window and set our window to the appropriate values. So I'm actually going to go over here. Let me copy this table and bring it over here to this slide so that we can see it at the same time. So whenever I look at the window, I see X min, X max, X scale, and then Y min, Y max, Y scale. And then we have this X resolution here. We don't really need to mess with that ever. So the X min that I see is the lowest X value that I have. Now my lowest X is 7. However, I might be interested in what happens all the way up to the X axis here. So I'm going to go with 0 as my lowest in this particular case. And then my highest X is 18. But I would like to see a little beyond 18, so I'm going to make that maybe 20 here. Now you'll notice that you might set your values a little bit differently, and it will look still pretty good. XSCL, that stands for X scale, and that just tells us what to count by on our X-axis. 0 to 20, I can probably count by ones just fine. If I wanted to, I could change this to 2 or 3. But I think I'll just leave it 1 here. For grade, I have from 2nd grade all the way up to 12th grade. But it probably would be interesting for us to go from 0 up to, we need to go past 12. So we could set it as something like, 13 or 14. I'm just going to go with 20 here as well, even though 20 doesn't really make sense for grades, because it will make my window the same for my X and Y. You don't always have to make the window the same for the X and the Y, but because these are still pretty close to each other, it will probably be beneficial for this problem. So we have our windows set to appropriate values, and now we are going to press graph. And we should see this show up here. Now I have, it looks like a line here. It looks like I've got something extra right here on this screen. So I'm going to hit Y equals, and notice here I've got this big long equation. That was the line of best fit that I just found, and it is stored in my Y equals for me, so I didn't even have to type it in. But my calculator has an extra line stored in it. So right here, I need to clear that out. And then if I hit graph, you can see now that line over here in the corner is gone. So this gives me an idea. Now notice not all of these are perfectly on the line. If you think about the situation here, and you think about the kids in this class, some of you guys are 14, some of you guys are 15, but both of you are in the 9th grade. So the age doesn't exactly give us the grade that you're in, but it will give us something close to the grade that you're in. So all of these points don't fit perfectly on the line. So now that we have this line, we could use it for a lot of different things. If we know somebody is 8 years old, we could use it to predict what grade they would be in. Or if somebody is 16 years old, we could use that to predict what grade they would be in. Now, this is a very simple situation that I just wanted us to use for this first example. So it doesn't, you know, we wouldn't really collect this data very often. So hopefully that gives you an idea of how to enter your data into L1, L2, find a line of best fit, and then graph a scatter plot. So those are all things that we have to be able to do. So now let's look at some examples where we'll need to do that. So first of all, I want us to think about what the calculator. So here is a table, and this table gives us the distance to and from Chicago. So all of these flights are to and from Chicago. So you'll see from, if we're going westbound from, let's see, if, for example, if we're going westbound from Germany to Chicago, it's 550 minutes. Whereas if we're going eastbound from Chicago to Germany, we see that that would take 490 minutes. You have a difference here because of the jet stream pushing you one way or the other. So my question that I want to know is how is the distance and the westbound flight time related? So what I'm going to do for this particular situation is I'm going to ignore my eastbound column here. So we are not going to use it just yet. So let's, with our calculators, find a line of best fit, and I'd also like to see a scatter plot. So if I'm asked to find a line of best fit, for this data, then I will go to Stat and Edit. I need to clear out my L1 and L2, so I will clear this, and I will go up here and go up, hit clear, hit enter, and it clears out those lists. And then I'm going to type in the data that I'm given. My distance is my X, my flight time is my Y. So for distance, I will type those in. Okay, then I'm also going to type in my westbound times. Okay, and then you'll want to look over those lists to make sure that you have them correct. Okay, so we have our data typed in. Now we can get us our line of best fit. So if we hit Stat, we go over to Calc. We're going to pick number 4 here. Make sure before you hit enter, we want to store this in Y1 so that we'll graph the line for us. So we're going to hit Stat. We're going to go, oh, sorry, wrong one. We're not hitting Stat. Quit. Go back here. Hit Bars. Go over to Y bars. We're going to hit enter for function and enter for Y1. And now we can hit enter. It will give us our linear regression. So we see here that if we round to 3 places, our line will be y equals 0.117x plus 51.581 if we round to 3 places there. Notice that our data gives us a pretty good fit because we have 0.9988918 for our R value, so that's a pretty strong correlation coefficient that we have there. So this is our equation. Let's also get us a scatter plot for this. So we're going to hit Stat. We're going to go over to Calc. No, we're not. Don't do that. We're going to do second, Y equals. See that our stat plot is already on from where we graphed before. So if we hit Graph, notice nothing shows up. But remember that our window for the last problem that we did was just 0 to 20. Well, if we look at this window here, we definitely need to change what we've got. So if we hit Window, if we look at our list, our lowest distance is 195. So 195 is pretty close to 0 when you consider the biggest is 7,790. So I'm going to just go ahead and type in 0 for my X. The highest number is 7,790, so I think I'll use 8,000 for my highest number there. Now, we do not want to count from 0 to 8,000 by ones, so I would probably count by maybe 500 here. So that way our tick marks on the x-axis will be a little more spaced out. Whenever it comes to flight time, 55 is still pretty close to 0, considering that our highest number here is 950. So I'm just going to leave this 0, but 950 is my highest time, so I'm going to probably use 1,000 here, so I'm going to use 1,000. And again, we do not want to try to count from 0 to 1,000 by ones. So I would probably count by maybe 100 here. Increments of 100 will give us a pretty good view. So now that I've got my window set, if I go back to the graph, now I see all of my points. And you can see that those points look very nice there, very close to the line, and this makes us feel pretty confident that what we have here is right. Now that we have this line, it could be used to estimate different things, and useful if we knew that there was a distance between Chicago and Charlotte. Then we could estimate how long that flight would take. In fact, let's actually look that up. So I paused there for a second and I looked up flight time from Charlotte to Chicago, and I found that it was 587 miles. So if we knew that from Chicago or I guess since that would, we really want to be westbound, we really should say Charlotte to Chicago. So that is 587 miles. So if we plug 587 miles into our line, y equals 0.117 times 587 plus 551.581. If we type that into our calculator here, we've got, let's go back to the main screen, we would have 0.117 times 587 plus 51.581. We type that in, we get that y equals 120.26, and this is measured in minutes. So roughly 120.26 minutes, which is just about exactly 2 hours. So we could use our line to make these different predictions of flight time, and that could be useful for us. Of course, if we were actually doing this, we would need, a little more information, probably some more cities that we would be interested in looking at. So that is all we're going to do today with this, but on Monday we will continue and do some more practice with these types of problems.